Welcome. In this video, I'm going to show you how we can write infinitely repeating decimals as an infinite series. So let's begin with this one, 1.0212121. And this 1 in front here, we can just write that out as a plus 1. What I mean is we have 1, and we're going to add something in each place. So this is the tens place. And how many, what do we have in our tens place? We have 0. This is 0 over 10. Now, what about this one? Here we have our hundredths place, but that's not where we finish repeating. We finish repeating here at the thousandths place. So this will be 21 divided by 1,000. And that takes care of this 21 right here. Okay, so now we're going to have this 21 divided by some number. Pause your video and see if you can figure out what that number is. So that's 21 over 100,000 is what you should have figured out. And then let's keep going. This last 21 here is 21 divided by, pause your video and see if you can figure out what comes next in this denominator. All right, if you wrote down 10 million, you're correct. Now, what is the pattern here? Well, it looks like every single time we add a fraction, we add some zeros in the denominator, that is some zeros after the 1, and namely we add 2 zeros at the end of each denominator. So let's see if we can figure out how to write this as a sum. So we're going to have 1 plus the sum from n equals 1 to infinity. And this starting point, this starting point here of n equals 1 will be helpful. So this is our n equals 1 term. This is our n equals 2 term. N equals 3. So when n equals 1, we want a 21 in the numerator. And in fact, every time we want a 21 that does not change in our numerator. So that's here. Now our denominator, when n equals 1, we want the denominator to be 1,000. When n equals 2, we want the denominator to be 100,000. When n equals 3, we want it to be 10 million. So clearly we're going to be using powers of 10. So how can we write these out as powers of 10? Well, this one here, actually I'm going to scooch these over very quickly. You'll see why in a sec. So this first one is 10 to what power? This one's 10 cubed. This one's 10 to the 5th. This one's 10 to the 7th. So now you can see this pattern that we want to actually start with odd numbers. And to express an odd number, all we need is this. We need 2 times n plus 1. This tells us on our first term n equals 1, change that n to 1, and then add 1 to get a 3. For our second term, for 2n plus 1, we're going to write 2 times 2 plus 1, which is 5. And go ahead and check for yourself that it does also work for n equals 3. All right, you should have checked for yourself that this pattern does indeed work for n equals 3. And here we have this value written as an infinite series. Next, let's look at this decimal as an infinite series, or let's rewrite it, that is. And by now you should see that any whole number up front you can just write out. So this is 21 plus some series. And well, before we even get to the series part, let's look at our repeats. Our repeats are every 1, 2, 3, 4 digits. 3, 4, 2, 1. Then 3, 4, 2, 1, and 3, 4, 2, 1. So let's begin by looking at these 4 digits. Clearly, we're going to want a 3,421 in our numerator. Now, to figure out the number of zeros in the denominator, think back to elementary school to place value. This is the tenths place, the hundredths, thousandths, 10,000ths. So we want 10,000 in that denominator. And let's look at this value, and I should color code these better. There we are. So 3, 4, 2, 1 in our numerator. And now for the last part, so our last number, if you recall, we repeated every 2 digits. So we basically added 2 zeros here to the end of the previous number for the new denominator. Here we repeat every 1, 2, 3, 4 digits. So let's see, how many zeros do we have? 1, 2, 3, 4. Now we want 8 zeros. Okay, let's do this one last time. For this 3, 4, 2, 1, we now want 12 zeros. So clearly this is easier to write as if we use powers of 10. So this is 21 plus 3,421 divided by 10 to the 4th plus 3,421 divided by 10 to the 8th plus 3,421 divided by 10 to the 12th. And so our series will look like this: 21 plus the sum from n equals 1 to infinity. This is our n equals 1 term. Our numerator remains fixed, so it does not need any ones attached to it or multiplied, added, nothing. Our denominator, if you notice, is always 4 times this value. 4 times 1 is 4, 4 times 2 is 8, 4 times 3 is 12. So this will be 10, I don't want this in pink, 10 to the 4n power. I hope this video has been helpful.